Such a big expression will not appear on the GMAT, but for conceptual clarity, let's take this complex example. If you can solve this, you can, of course, solve the easier ones. So, if this expression is greater than 0, which of the following specifies all the possible range of values of x? This is the question. Let's see how to solve these questions. The concept is that in such questions, factorize the terms and equate each factorial to 0 to get different nodes. So this is what the expression is. This can be factorized into x minus 2 times x minus 3 times x plus 6 times x plus 5. This entire expression is greater than 0. Now the concept is that you have to equate each term to 0 to get the nodes. The value of this polynomial would be 0 for 4 different values of x, the 4 values for which each of the 4 terms becomes equal to 0. These values are 2, 3, -6, and -5. The next step is to represent these nodes on the number line. These are the 4 values, and we have to think of what happens to the sign of the polynomial as per these values on the number line. Now imagine these 4 terms are being multiplied: x minus 2, x minus 3, x plus 6, and x plus 5. The smallest of these values is x minus 3, represented by this node, 3. So in this range, when x is greater than 3, what happens? The smallest of these 4 terms, this, becomes positive. If this becomes positive, the other 3 also, of course, become positive, and therefore the value of the product is going to be positive. At x equals 3, the value of the product will, of course, be 0, because one of the 4 terms becomes 0. Next, between 2 and 3, what will happen? X minus 3 will become negative, while the other 3 terms will remain positive. So effectively, we will have 1 negative sign and 3 positive signs, leading to a negative value of the polynomial. At 2, x minus 2 will become equal to 0, and therefore the value of the product would be 0. Now, between positive 2 and -5, what would happen is that x minus 3 would be negative. X minus 2 will also be negative, 2 negative signs and 2 positive signs, because the other 2 terms will continue to be positive. So the product, 2 negative signs times 2 positive signs, effectively lead to a positive value. Next, x equals -5 is a value where x plus 5 will become equal to 0. And in this range, between -5 and -6, x plus 5 will become negative. X plus 6 will remain positive, while the other 2 terms will also be negative. Overall, we now have 3 negative signs and 1 positive sign. Effectively, we will have a negative value in this range. Lastly, below -6, all the 4 terms will become negative, and therefore, practically, we will have a positive sign, a positive value of the polynomial. So the graph would look something like this. See rightmost positive and then alternate negative and positive signs. Okay, so the question seeks positive values of the polynomial. The answer would be x is greater than 3, x is between -5 and positive 2, or x is less than -6. These are the possible values. Important tip: to save time, simply mark the rightmost region as positive. This area will always be positive, and thereafter, you will have alternate negative and positive signs. Let's take some examples. Look at this one. Please pause the video, draw it yourself. The 3 nodes involved are 0, 1, and 6. That is when one of the 3 terms become equal to 0, respectively. Then you know that rightmost you will have a positive sign, and then alternately negative and positive signs. So this is what the graph looks like: positive, negative, positive, negative. The question is asking for negative values. Therefore, the required ranges are x between 1 and 6 and x less than 0. This was the concept, friends. GMAT shots are deliberately kept brief. For an elaborate explanation, please watch the Stage 1 conceptual videos in our program. Thanks for watching.